Okay, you should have your journal, your Unit 4 Day 1 notes, scissors and glue out. And we're going to get started. We are on Unit 4 finally. So you can put Unit 4. This is called linear functions. Okay, linear functions. So get your cover page set up. If you notice, the word linear has this little word in it right here. Line. That's because when you talk about linear functions, you're talking about functions that when you graph them, they're the graph of a line. So a lot of what we're talking about in this unit has to do with lines. So get that all written down. You won't need to cut anything out quite yet. We've got a little bit to write first. And part of today is going to be a little bit of review. And then we're going to talk about what's called parent functions in just a minute. Okay, let's go ahead and get started. So this is day 1. So today, the first thing we're going to do is domain and range from a graph. And so this is kind of review for a lot of you, but I just feel like we never really cover this quite as well as we need to. It's something that's going to be tested. It's something that you have to know and I have to be able to teach you this year. So I just want to make sure we've done a good job at it. And so we're just going to kind of review this, our lessons. So if you already have this down, it should be a really easy lesson for you. Let's go ahead and review what domain and range are. So for review, domain. Which variable does domain go with? Domain is all the x's, correct. So domain is all possible input or x values. All the possible input or x values for a function. Which means range is all possible output values, or y, for a function. Domain is all the input, range is all the output. Okay, and depending on what your graph looks like, when you're looking at these from a graph, could depend on what your domain and range looks like. If it's just a bunch of dots, then your domain and range is just those numbers, those specific numbers that go with those points, because it doesn't include any of the stuff in the middle. But most of the time, you're looking at some kind of drawing or a line segment or array, which means it has a point on one end and an arrow on the other end and goes on forever. So you're looking at different shapes and things like that. So those things require us to use some symbols to show what the domain and range are. So the symbols we're going to use, I want to make sure you understand what the symbols are, because usually every year there's a lot of confusion with these. So we're just going to go over all of them, make sure you've got these down. So the first one looks like that. And we're not going to call these Pac-Man or alligators or any of that other nonsense. This is less than. Okay, and the reason I don't call it that or explain it that way is because on testing, they're not going to say the alligator is eating the bigger number or anything like that, okay? So you've got to know that that's less than. So, for example, if I say x is less than 6, that means all x numbers are smaller than 6. They're all smaller than 6. They don't include 6. They all have to be smaller than 6. 5.99999 is smaller than 6, so it would be okay. But 6 is not included. Okay, only things that are smaller. Okay, so then this one is greater than. So if you have the example x is greater than 6, what does that mean? numbers are bigger than 6. Again, 6 is not included. It has to be at least 6.1 or 6.00005 or something that's bigger than 6. 6 doesn't count. It has to be bigger than 6. Okay, then there's two more that we use a lot with these, and for some reason a lot of times my students don't recognize these. I don't know if you don't use them as much in 7th or 8th grade, but we're going to go over those also. So there's this one that has a line under it. This is less than or equal to. So if I have that example, x less than or equal to 6, that means all x numbers are either 6 or smaller. They include 6, or they can be smaller than 6. So 6 is included on this one. So the last one is going to be greater than or equal to. And so our last example, x is greater than or equal to 6, would mean all the x numbers are either 6 or bigger. Okay, so it's really important that you understand what those are. Okay, and you always read them from the variable. Wherever the variable is, that's the direction you read it from. And I'll have to explain that a little bit later. But there's one more thing on a graph. You notice how on graphs, and if you look at your notes page, you can see this, that there's circles at the ends of the lines sometimes. Those are dots. Some of those dots are open. Some of those dots are closed. The ones that are less than and greater than, those are open circles. So these are open. The ones that have the line underneath them are closed. Why do you think that is? Anybody have an idea? Okay, so it's kind of like, you know those big metal iron covers that are in the street that like the workers go to work down like in the sewage and drainage ditches and whatever. They have those big round circular covers in the middle of the street or in the middle of the sidewalk. Those things are called manholes because men go down in there and work. So if that cover is there, can you stand in that spot? Sure. Could you drive over that spot? Sure. What if the cover's not there? Could you stand in that spot? Well, not unless you want to fall. I mean, you just fall straight through, right? And you probably wouldn't want to drive over this spot because you might get a flat tire or something. So if the cover is there, it includes that spot. But if the cover's not there, that spot's not included anymore. So if you look, the ones where it doesn't include the 6 are open. You can't stand on that 6. But the ones that it's included, you can stand on those. So it's like that cover in the road. So just kind of think of that whenever you're doing that. Okay, now that we've got all that, I want you to cut out 1 and 2 together. So that we're not doing quite so much cutting, we're going to cut 2 at a time. So we're going to do 1 and 2 on this page. And we're going to do the other 3 sets on the next page. Hold on just a second, I'll show you. Okay, so glue 1 and 2 down right here. Just kind of down at the bottom. There's 1 and 2. And what we're going to do is find domain and range from each one of these graphs. so get those cut out. I'm going to go ahead and cut mine out while I'm waiting on you guys to get those cut out and glued down. I've got a little bit of stuff to cover today, so I don't want to take too long. I want you to be able to have a little time to work on your assignment while I'm still here, so you don't go home and have no clue what you're doing, because sometimes that happens in math. You kind of get it in class, and you get home, and you don't remember anything. It looks like a foreign language. Yeah. Okay. Looks like most of you got that done. All right, so on number 1 and number 2. First thing underneath here, we're going to do domain. And then range is what we're doing on both of these. And domain and range is a set. So you have to use these little bracket things. I call them squigglies. So make sure your squigglies are there. That's a very technical Texan term. So domain squigglies. So make sure you got your little squigglies. If you don't know how to make the little squiggly brackets, just do a squiggly line. It's your journal, so nobody cares if your squiggly line's not perfect. All right, so here's what we're going to do. We've got this line segment, and I'm going to zoom in a little bit, just because sometimes the graphs are hard to see. So we're going to zoom in on this. So I've got this ray, and it's a ray because it has a point on one end, and then it has an arrow on the other end. What does that arrow mean? The arrow means it goes on forever, infinite. Okay, so it goes on forever and ever and ever, that direction. All right, so in order to kind of figure this out, what you need to know is, where does the x start? Where does the y start? Does the x end or the y end? Well, obviously this has one dot, so it has a starting point. Does it have an ending point? No, because it has an arrow right there that says it goes on forever. Forever means no ending point. So it only has one dot equals one number. So if you have one dot, you're going to have one number. And if you look at this, the x starts at, and remember x goes left and right. This is your x-axis right here. So if I'm looking at this, the x starts at, what number is that? -3, it looks like. And then what does it do? X can only go left and right, so if you're looking at this arrow that's kind of going down-ish, but it's also going which direction as far as left and right? Down and to the right. So it starts at -3 and then it goes that way. So I'm going to put a little arrow that says that way. So on my domain, it's always going to be my x's, so put an x there. The one number that I've got, because I know where it starts, is -3. Starting at -3, if I go that way, to the right, are my numbers getting larger or smaller? If I start at -3 and go to the right, they're getting larger. Is that less than or greater than? I mean, this isn't complicated, right? It's greater than. So you're going to do a greater than symbol. Last thing you have to check on every one of these. Is there a cover? Is -3 included? Could I stand there? Or is there not? So could I stand on -3? Yes. That means you got to underline it. You're done. And if you're not getting it, it's okay. Just stick with me, work with me, do these notes. You'll get it by the end because we're going to practice it a few times. Okay, range is all the y numbers. So put your y there. The y starts at, we got to figure out where the y starts. Y starts at this spot right here. How far up is that? 2. So it starts at 2, and then what's it do? Does it go up or does it go down? Because y can only go up or down. That's the only options. So would you say it goes up or does it go down? This one goes down. So it starts at 2 and goes down from there. So my number's 2. Would down be less than or greater than? Obviously less than. It's getting smaller. And is the cover still there? Can I still include that? Yes, you can still include that. Underline it. That's it. That's domain, and that's range. And you are done with that. So make sure you get those written down. The next one's a lot easier, but you're not going to have too many like this because we've already done a lot of these. So make sure you got this one written down. We're going to do another one like it in just a minute. Okay, look at number 2. I'm just going to put D for domain, and then put my squigglies, and R for range. Okay, on number 2, what's different about that one versus the first one we did? It's a bunch of dots, right? It doesn't have a line. It's not connected. None of these dots are connected to each other. Okay? If it's a bunch of random dots, your domain is all the x numbers for all the points. Your range is all the y numbers for all the points. So the easiest thing to do is to write down the points. If you write down the points, you have all the x's and all the y's. So let's go through here and write all the points down. And I'll mark them out as I go. So let's do A is 1, 2, 3, 4. Up 1, 2, whoops, 1, 2, 3, 4, 5, 6, up 6. 4, 6 is A. And I always X them out as I go, so that way I know I did them. Okay, B is 1, 2, 3, 4, 5, 6, 7, negative 7. Up 1, 2, 3. C doesn't go left or right, so that's 0. Positive 7. D is a negative 3. 0, that one's easy. E is negative 1, 2, 3, and down 8. And then F is over 1, 2, 3, 4, and down 1, 2, 3, negative 3. So we're going to write the domain and range. Domain is all your x numbers. Range is all your y numbers. Don't repeat a number if it's in the list more than once. So domain on this one is 4, negative 7, 0, negative 3. And I'm not going to do the negative 3 twice, and I'm not going to do the 4 twice. And then range, nothing repeats, so let's just write them all down. 6, 3, 7, 0, 8, negative 3. Simple as that. Okay, hopefully you don't have any questions over that one because we've done a lot of those before. We just haven't ever done the ones that have like a line going on over here. Okay, get those written down and cut out 3 and 4 together. We're going to go glue 3 and 4 at the top of your page. And then 5 and 6 kind of in the middle. And then skip a few lines and do 7 and 8. So let me zoom out so you can kind of see my page a little bit. So we're just going to skip a few lines between each one because you need to have enough to write underneath the 7 and 8 at the bottom. So just kind of spread those out and glue them down on that next page. Glue down. You can put your scissors away, you can put your glue away. Don't get up and actually put it away right now, but just put it to the side or on the floor until we finish our notes. And then once we finish, you can get up and put them back in the container. Okay, number 3, I'm going to go ahead and put my domain and range and my squigglies down here. Number 3 is a lot like number 1. How many dots are on number 3? 1. There's 1 dot. This is an arrow on the end down here. If you're not sure, make that arrow bigger so that you can tell. Okay, so there's 1 dot, which means we're going to have how many numbers? 1 number. Domain is all the x's. So in my squiggly, I know I can put an x in the front. Range is all the y's. I know I can put a y in the front. Go ahead and fill that in. I'm just kind of getting stuff filled in, I know. Okay, now looking at this, we're going to say this dot is right here. So the x starts at what number? 1, 2, 3, 4, 5, it looks like. Starts at 5. And you had to say, does it go left or does it go right? And you couldn't say up or down. You could only say left or right. Which one would you say? You would say left. So it starts with a 5 and then it goes that way. So I know my x number is 5. Is it getting less than or is it getting greater than? It's going to the left. So it's starting at 5 and going that way. Are those numbers getting bigger or smaller? Right, they're getting smaller. So that's a less than. And could I stand on that 5? Is that 5 included? No. So don't underline that one. Leave that arrow alone. Okay, leave it alone. All right, for the y. Y goes up and down, so y starts at, looks like -2 to me. Starts at -2, and then from there, would you say it goes up or it goes down? That's your only two options. You can't say left or right for the y. So y can either go up or go down. This one's going up. And up is going to be greater than. You'll see how this is kind of working? So my number for y is -2. My arrow for y is starting here and then it's getting bigger. So it's going this way. Nobody snuck in there and put the lid on the 5 or the 2 or the -2. So we still can't stand there at that point. It's still not available. So don't underline it. You're done. That's all you're doing. You just have to decide, are they getting greater? Are they getting smaller? I'm starting here, because if you said that the x was getting bigger, if you said greater than, somehow over here it would be all included. There's nothing on the graph over there. There's no way that can be included. There's no way I can have a point at 10, 2 on this particular line. That's never going to happen. Okay, so number 4. Go ahead and do your domain and range down here. What do you notice is different about this one? What's different about number 4? Yeah, it's got 2 dots, right? It's got a dot on each end. So earlier I said we had 1 dot, so we have 1 number. We've got 2 dots. What do you think is going to happen? 2 numbers. Funny how that works. Okay, 2 dots, 2 numbers. The cool thing is this x and y, it's going to go between this dot and this dot. Between this dot and this dot. We're looking for just that space between. Since it's between things, since it's in the middle, your letter gets to go in the middle. So go ahead and put your x and your y in the middle this time, because it's in the middle of 2 dots. So if there's 2 dots, your variable's in the middle. If there's 1 dot, your variable's on one end and goes one direction. Okay, so 2 dots, the variable's in the middle. You need to look at this and go, okay, x starts at what number? And remember, we want to go least to greatest. So there's where it starts. Here's where it ends. It goes from here all the way over to here. Everybody see how I'm figuring that out? This dot lines up with that x number. This dot lines up with that x number. So it starts at -1, 2, 3, 5, 6. -6 ends at +1, 2, 3, 4. Starts at -6, ends at +4. So those are your 2 numbers. -6 goes here, +4 goes here. If you'll put them every single time, least to greatest, so smallest to largest, then the cool thing is your arrows will always go the same direction. They'll always go to the left, like Beyonce. Okay, to the left. So, yeah. -6 is the smallest. +4 is the biggest. Arrows to the left. What is the last thing I need to check, just to be sure? What's the last thing we check? Yeah, is the cover on or is the cover off? So at the -6, is the cover on or off? It's off. Do not underline that arrow. But at the +4, what's the cover doing? It's there. Can I stand on the floor? Absolutely. So underline that one. Okay, so remember, y goes up and down. So y is going to be anywhere from here all the way up to here. So So y starts at -2, it looks like, and ends at positive 1, 2, 3, 4, 5, 6. So as long as I go least to greatest, I can just put those numbers in there and go to the left. And then I just have to look to see if I can stand. Can I stand at -2? Here's my -2. Can I stand there? No. But can I stand at +6? Yes. Underline it. Now sometimes those won't match up. Sometimes this one will be underlined and not this one. Okay, sometimes they won't match the domain and the range as far as the arrows go. They'll both point to the left, but one may be underlined and the other one not, and that's okay. You might have this one underlined here, but this one underlined there. It just depends. All right, look at 5 and 6 now. 5 and 6 is like the one we just did. Both of these are. So go ahead and do domain with your squigglies, range with your squigglies. That's a terrible squiggly. There we go. There's 2 dots on number 5, so how many numbers am I looking for? Looking for 2 numbers. Where's my x going to be? In the middle. So it's between these 2 dots, so it needs to stay between the 2 numbers. Range is between those 2 dots. It's going to stay between those 2 numbers. What do I know about my arrows? To the left, right? So, arrows go to the left. Make sure they're going to the left. As long as you go least to greatest on the numbers, which we're going to do, we can go ahead and put our arrows to the left. We're good. Okay, and if you look at those, they're both colored in, so that's super easy. I don't even have to worry about which number is which. I can stand at both spots, so I'm going to go ahead and underline them. That way I don't forget. All right, we got our arrows all set up. All I need now is what numbers I have. I don't know what numbers they are. How do I figure that out? Right, I'm going to look and see where it begins and where it ends. So this one, it's that x and then that x. So from here to here is where this covers. So this x starts at -1, 2, 3, 4, 5, 6, 7, 8. -8. And ends at +2. So there's my 2x numbers. -8, +2. I've already done the arrows. I've already put the x in there. I've already even got the squiggly on the end. We're good. That one's done. Okay, then the y numbers go from here to here. So y starts at -1, 2, 3, 4, and ends at +1. So -4 is smallest, +1 is largest, so -4, +1. I've already done all the arrows, I've already done the variables, I've already done the squigglies, I'm all done. That is it. Okay, I want you guys to see if you can do number 6 all by yourself. And I'm going to freeze frame it, and then I'm going to do it and unfreeze it and see if you guys got it right. So make sure you're writing domain, put your little squigglies there, range, put your little squigglies there. How many dots do you have? 2. How many numbers do you need to find? 2. Okay, you're looking for what's in the middle. So that should tell you about your variable. Okay, if you're not ready, don't look because I'm going to unfreeze it. If you're done, you can check yours with mine. See if you got it right. Awesome, y'all getting it right. Good job. Okay, so we've only got 2 more to go, and then we're going to talk about parent functions just a little bit today. But yeah, any questions on that one that you guys did? No? Okay, good job. Let's move on. Okay, look at number 7. Let me zoom in really close to number 7 so you can tell the difference here. What's different about number 7 than all the ones we've done? It's completely different from any of the ones we've done so far. Completely different. While you're thinking about that, I'm going to put domain, squiggly, range, squiggly. Okay, yeah, there's no dots. What is there instead? I've got arrows. I've got arrows right here. I've got arrow right here. What do those arrows mean? That means it goes on forever. So this one's going on forever up and to the left and down and to the right. And it's going forever, okay? So it's going forever and ever both directions. So if it doesn't start and it doesn't stop anywhere, I don't have any points. Well, go if we had 1 point, we had 1 number. If we had 2 points, we had 2 numbers. I don't have any points. Guess what? It's not 0 numbers, let me tell you. It's every number. Okay? And every number is all real numbers. So this one's a little bit, I tricked you a little bit on that one. 1 point, 1 number. 2 points, 2 numbers. No points, every number. Okay, so that one's kind of backwards. So it's all real numbers. That means this is going to cover all the x's eventually, and it's going to cover all the y's eventually. So if you see a straight line and it's got arrows on both ends, and it's not straight up and down or horizontal, it's not vertical or horizontal, then you know domain is all real numbers, range is all real numbers, every single time. Okay? As long as there's no dots, no endpoints where it stops, then it's all real numbers, all real numbers. That one should be like the easiest one there is. All right, last one of these. I've got this shape, this rectangle. Okay, we're going to see what x's does this cover, what y's does it cover. So the x's start at, let's get a different color. They start right here and end right here. Y'all see that? This x is covering from that point to that point. That's how far the x's are going. So that is negative 1, 2, 3, 4, 5, 6. Negative 6 ends at positive 1, 2, 3, 4, 5, 6, 7, 8. Positive 8. So x is in the middle, arrows to the left, negative 6, positive 8. Last thing I need to check is, do you think you could stand on the negative 6 or the positive 8 spot on this rectangle? Is that line a solid line? Like, is it covering that negative 6? Yes. Is it covering the positive 8? Yes. So we're going to go ahead and underline those. Which means you can kind of get set up on your range down here. Put your y in the middle. Put your arrows there. We just got to figure out what numbers it goes with. Okay, so y goes from here to here, which means it's covering all the way between those two. So y starts at, and we got to go least to greatest, so we got to start at the bottom. Started from the bottom, now we're here. Okay, so starts at negative 3, goes all the way up to 1, 2, 3, 4, 5, 6, 7. Ends at 7. Y'all know I'm a little goofy, so that's why I say things like that. Okay, so it starts at negative 3, ends at positive 7. There's your domain and range. You did an amazing job. Awesome, we are done with that. Good job. Okay, so all I have to do now is just kind of show you parent functions. It's not anything hard. They're just kind of something you have to recognize. And it's going to be on your assignment, so I want to make sure we cover it so that you'll do good on your assignment. So make sure you've got that written down, and we'll go to the next page. Okay, so last little bit of these notes is parent functions. And basically for right now, parent functions are just something that you need to be able to recognize, know what they are, and know what they go with. Okay? Parent functions should be easily recognizable, that they go with a certain category of a type of function. Okay? It's kind of like, usually, not always, but usually kids kind of look like their parents. So you can usually tell when you see a family, you know, those kids go with that parent or those parents. Not always, because our world is a lot of different mixtures of people and hair colors and eye colors and skin colors and all that kind of stuff. And so it's not always exactly, and there's always other ways to be parents besides biologically. So it doesn't always work out that way, but just kind of think along old-fashioned lines, I guess, as far as that goes, and think a parent function goes with the category. Okay, I always say it's the most boring, most basic function of the group, which most of you probably think your parents are boring. They're probably basic. So they're the most boring, most basic function of the entire group. So parent functions, we'll just define them. These are the most basic function in a specific category. Okay, we need to recognize 4 types. There are other types of parent functions, but the 4 we're going to deal with are the 4 I'm going to talk about today. Okay, we're only dealing with 4 types in Algebra 1. You won't deal with the other ones probably, maybe in Algebra 2, maybe in pre-calculus or calculus, but not at least until Algebra 2. So the first one goes with the unit we're on, and it's a linear parent function. Linear. The equation for a linear function is y equals x. It's real basic equation. And here's what the graph looks like. So draw yourself like a little graph here. The parent function starts at, or doesn't start at 0, but it goes through the origin, which kind of makes sense because parents are usually the origin of the family. So it goes through the origin, and it's just a positive slope. And if you looked at the table for a linear function, this would be 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Okay, that's the parent function. All the points match up on a linear one. So it's super easy to recognize. That one should be really easy. That's just the most basic line we have, the most basic equation, the most basic graph. Okay, the next one, which we will use this year, is quadratic. So linear is a line. Quadratic, the equation looks like this, y equals x squared, and we'll talk more about that later. You don't even have to have that memorized right now. So we'll talk more about that later, but I want you to draw your little graph right here. This graph is called a parabola. You might have seen that before, parabola. And it looks like this. It's a U. Okay, the way you can remember this graph is Q is always followed by a U in the English language. Q goes with U. So quadratic, the graph better be a U-shaped graph. All right, QU. Queen, quilt, quit, quiet, all those words, quack, they all start with Q, they all have a U right after it. The only ones that don't are some proper names when people choose to leave that off, and that doesn't count. Okay, so linear and quadratic, these are the 2 that we use a lot in Algebra 1. Linear more than anything, quadratic we use a little bit at the end of the year. Okay, the other 2 that you need to recognize but we aren't going to use at all this year are the absolute value graph. An absolute value graph, the equation is y equals the absolute value of x. And here's what the graph looks like. So Q goes with U, value goes with V. Okay? So Q, quadratic, goes with U. Absolute value is a V. So if you see value, V. The only thing you need to know about this one is that's what it looks like. That's all you need to know right now. We don't use this graph in our stuff that we have to learn this year. I just want you to be able to recognize it and know what it is. Okay, then the last one, again, we won't use this one, but you need to recognize it. It's called exponential. And this equation is y equals e to the x power, which is kind of weird, I know. It's one of the reasons why we don't use it much. This one you use a lot more in Algebra 2. in pre-cal. So y equals e to the x power. This is the only one of these parent functions that doesn't go through the origin. The only one. This one looks like this. It starts at the 1 and it has an ending point. It starts up there and it curves up like that. That's an exponential one. You don't need to know much about it other than that's what it looks like, and that's what it's called. Okay, exponential, so it curves up. That's all you need to know about that. That's your parent functions. That's all your notes for today. You should be able to do your assignment 4-1 pretty easily. I would get started on it so that if you have questions, you can get those answered in class.